Hey boys and girls, back in my room again. It's Monday, May the 4th. May the 4th be with you, right? It's funny, right? I know you guys don't like my jokes. But since we started talking about wind, today you guys got that assignment. I told you how wind was produced. We're going to take it a step further and we're going to start talking about another part of the wind. We give certain winds certain names. Today we're going to talk about a sea breeze. Now, obviously, we don't call the ocean right beside us the sea, but that's the same type of thing we want to kind of talk about. This sea breeze blows pretty much every day, and I'm going to show you why it blows every day around these big, huge bodies of water. Not necessarily a small little pond. You got to have a huge body of water in order for this equation to happen. Okay, so this sea breeze does not blow in places that does not have an ocean or a sea or a gigantic lake beside it. So somewhere like Raleigh or Charlotte, Greensboro, places like that, they do not have the privilege of having a sea breeze. We do because we have the ocean right beside us, and you know why the wind blows. It's because of uneven heating. Now this sea breeze, since it doesn't blow in Raleigh and Charlotte, is going to be considered a local wind. Okay, local winds are winds that blow around the area you live in. Okay, so if you live in Wilmington, you can say that you are a local. You are locally born here. Hey, I'm a local. You know, I've been here my whole life. Well, the sea breeze is going to be something that happens around this area. And anywhere you have a beach, anywhere on earth you have a beach, because it's a perfect setup for uneven heating, which makes a sea breeze. Okay, we'll talk more about global winds. And if you don't know what a globe is, this is a globe. Global winds are going to be winds that blow throughout the globe, and they're consistently blowing all the time, pretty much. But we'll get more to that later. So we're going to talk about this local wind, this sea breeze. So if you recall my lesson today, you know that the sun causes all the wind to blow. We talked about this. Well, the sun causes uneven heating. Okay, these pressures that the sun makes causes uneven heating. So what we're going to start talking about is this sea breeze. Okay, so what do we need in order for a sea breeze to blow? Well, obviously, if you've been to the beach before, you have felt the breeze blow. Sometimes you felt the sand hit your legs or your face if you're laying down in the sand. The breeze is always blowing in the afternoon, and there's a reason why. So I'm going to use the orange for the hot and the green for the cold. And I know that's not the best thing to do, but I don't have a blue and a red, so we're going to have to do with this. That's the color of fire, so hopefully you'll get the idea. Now, sea breezes pretty much only blow during the day. Okay, so during the day, we're going to have a sun up in the sky. Okay, so what's the sun doing as soon as it wakes up in the morning and it comes over our horizon and starts to beat down on our earth? It starts to heat things up. And if you remember what I talked about today, you know that the one that stands still is going to heat up the fastest. The water, since it's constantly moving all the time, kind of stays the same temperature. You know, it takes a long time for water to heat up and cool down, especially when you have a large body of water like the Atlantic Ocean. That's a lot of water to heat up, and it's a lot of water to cool down, so the water kind of stays the same. So this sea breeze, you got to have two things. You actually got to have three. You got to have the sun, you got to have some land, and you've got to have water. And that land and that water have to have differing temperatures, okay? So the sun's out, beating down on us in the summertime, and obviously in the summertime it gets really, really hot around here when you guys usually go to the beach. A typical hot, sunny day around here is gonna be roughly about 88, 89 degrees, somewhere around in there. That's a good estimate. Obviously it can get hotter. It can also get a little bit cooler. But, you know, it just depends. Weather's a tricky, tricky thing. The water at this time of the year is about 65 degrees. Now, when you go in the summertime and you go to the ocean in the summertime, the water is not 65 degrees, okay? It is not anywhere close to 65 degrees. I'm actually gonna use purple because I don't think that shows up real well. So we're gonna go ahead and change that. I apologize, don't get confused. So let's say that's 65 degrees. Now, we have two differing temperatures, okay? We have 65 and we have 88. Do we have uneven numbers? Yes. 88 degrees is pretty hot, 65, not so hot, kind of chilly. So we have two differing temperatures, okay? Now this is how this happens. When the sun comes up and beats down on the land and the water, the land heats up really quick. Like I told you today, it's a sitting target. It heats up fast. Water is constantly moving, so it takes a long time. Something really interesting happens though when the sun hits the land and it gets really, really hot. It starts to generate a lot of heat. And when we were going over the water cycle, we talked about what heat likes to do. Hot things want to rise, okay? They want to go up. And if you want any evidence of this heat rising, go outside on a day like today. It's absolutely gorgeous outside. The sun's shining. The sun is heating up the land like it always does. And if you go outside and you see birds flying, and you see these gigantic birds we always see on the playground, you'll see that they don't really beat their wings too much. And the reason they don't is because when the sun hits the land starts to release heat. And it starts to go up into waves, just like this, okay? And when it's going up like that, it's creating a draft, a hot draft up, okay? And giant birds can use it to fly, all right? And that's what keeps them up in the air. So that's what happens is you get all this land really, really hot and the air starts to rise and it leaves a gigantic empty spot, okay? It leaves a huge empty spot that is like, hey, I need somebody to come and fill in the air that I just lost because all my heat just went up into the atmosphere. Well, if you take the other side of the equation where the water is, the 65 degrees, cold air, like we talked about during the water cycle, likes to dive and likes to go underneath hot air. So if you take this right here, you got all this hot air that has risen, then you need something to fill it back in with, and the cold air is what goes and fills in that empty spot. So wind begins to start getting generated because this colder air wants to go and starts to fill in this area, okay? And that is called a sea breeze. It is a recipe for a sea breeze. And the reason that they call it a sea breeze is because where does it come from? It comes from the sea. So it's a breeze from the sea, all right? So let's go over that one more time. The two things you need in order for the wind to blow is the sun and uneven heating, okay? The sun, you got land and water. You need those three things actually, water, land, and the sun. We have a difference in temperature. Where's the hot? The hot is over the land during the day because the sun's beating down on it. Hot air rises. Cold air goes and it wants to fill in where the hot air left, and this is what makes the breeze begin to blow. Now, I will tell you one thing right now. Well, actually, I'm going to wait till tomorrow after I go over a land breeze, okay? Let's just work on this sea breeze for today, and I'm going to have some questions for you, all right? And remember, you can hit me up with a question. If you have one, I'll try to answer it. I'm kind of getting used to this. I see some of your questions, and I see some, I don't see some of them. I don't know what's going on there. Maybe I just need to be a little bit more observant, but I've been looking. Let's work on this for today. Tomorrow I'll do a land breeze, and that'll get us started on winds, which the global ones are a little bit tougher to understand, so we're going to start off with the easier ones. I hope you have a good day, and this has been a moment in science. Sea breezes, okay?